In this video, we want to determine the zeros and their multiplicities for these polynomial functions. So first, let's talk about this idea of having a multiplicity. If a polynomial function has a factor of x minus c that appears exactly k times, then we say that that zero, which would be x equals c, is a zero of multiplicity k. So let's unpack that. What does that sentence mean? It means that you can have a zero that appears more than one time. So let's go ahead and find the zeros for these functions. So remember that the zeros are going to be the x values that cause the y value to equal 0. And f of x is a fancy way of writing y, so we're just going to be setting our function equal to 0 and solving. So 0 is equal to 8x times the quantity x minus 1 squared times the quantity x plus 3 cubed. Now, it's worth noting that this polynomial is in factored form. Both of these examples are. And remember, factored form can be seen because we have a product here. We're multiplying 8x times x minus 1 squared times x plus 3 cubed. So when we go to try to solve this equation, we're setting each factor equal to 0. That's called using the zero product property. So 8x is our first factor. We'll set that equal to 0. Our next factor is x minus 1 squared. We'll set that equal to 0. And then x plus 3, the quantity cubed, we set that equal to 0 as well. So we can divide by 8, and 0 divided by 8 is just 0. However, when you have x minus 1 squared, I want you to think about that as x minus 1 times itself. So that's really x minus 1 times x minus 1. And then if you were to set each of those factors equal to 0, see how you would get the answer of 1 twice. We would get x equals 1, but then we would get x equals 1 again. Now, as we move forward, we won't show all of this work, but I wanted to show this once so you could see you do get this 0 of x equals 1, and you get it twice. And that's because this factor of x minus 1, it was squared. That's what we call a multiplicity. So going back to our definition up here, it says if we have a factor of x minus c that appears k times, so in this example, our factor appeared twice, then that means we have a 0 with a multiplicity of k. So this is going to be a 0 that has a multiplicity of 1. So we could say x is equal to 1, and then if you wanted to put in parentheses after it, multiplicity of 2 to show that this appeared twice. That's one way that you could denote that. And then the same is going to be true for x plus 3, the quantity cubed. So again, if you were to write that out 3 times, you would multiply x plus 3 by itself a total of 3 times. And then in doing that, you can see when you set each factor equal to 0, you're going to get the same answer 3 times. Once again, as we move forward, we won't actually write all this work out, but I like to write it out once to show you that we do get the answer of x equals negative 3, and we're getting that answer 3 times. So we have a 0, and this 0 appears 3 times, and we could have seen that in the beginning up here from our factored form because of the exponent of 3. So we can say we have the answer, or the 0, of x equals negative 3, and then afterwards we could say that that is a multiplicity of 3. It appears 3 times. So our zeros are x equals 0. Now we don't have a multiplicity for that. It just appears once, and that was because this was x to the first power. Some people like to write multiplicity of 1, and that would be fine if you did that for me. Or you could just say no multiplicity. Then we have our next 0, which is x equals 1 with a multiplicity of 2. And then our last 0 is x equals negative 3, and that's a multiplicity of 3. So now in example B, let's try to do this more quickly and just look at the factored form and determine the zeros and their multiplicities straight from the factored form. So once again, if we're setting y equal to 0 to find our zeros, then we're solving this equation. And because it's in factored form, we're able to see the zeros and the multiplicities very quickly. So my first factor is the x squared. We know that's going to produce a 0 of x equals 0. But then we notice that we have the exponent of 2 which indicates the multiplicity. So we will write underneath here that we have a multiplicity, and I always just abbreviate that, a multiplicity of 2. Then our second factor is the factor of x plus 4. That produces a 0 of -4. So that's our 0, x equals -4. But notice the factor x plus 4 is to the first power. So that means we just have a multiplicity of 1. Or you could say no multiplicity if you wanted to. That's not a repeating 0. And then our last factor is x minus 5, which produces a 0 of +5. But again, we take a look at the exponent. That's to the 4th power, which indicates the multiplicity. So that's going to be a multiplicity of 4. So if you have a polynomial in factored form will help you determine the zeros very quickly, but it also tells you the multiplicities of those zeros.